Welcome to Khetz Tutorials, and in this video I'll be covering the average gradient. The average gradient is the gradient of a straight line joining 2 points. So let's say you have some sort of function, whatever the case may be. Now if you want to find the average gradient between this point and that point, you basically join or put a line in between the points or have the line cross the 2 points, and the average gradient will be the gradient of this line that connects the 2 points. That is the basic concept of the average gradient. And normally how you'd calculate the gradient of a straight line, this is how you'd basically calculate the gradient of a straight line. And the same principle applies even in this case, because we are indeed dealing with a straight line. So now let's say we have the Cartesian plane. Let me try to have this straight, and that is not straight, that is a bit better. So now let's say this is the x-axis and here you have the y-axis. Now let's say you have a point here, let's call it 1, and somewhere there maybe we have 5. Now between this point and that point we basically have a delta x. We basically have a change in x. To find this distance, we can call it h. To find the distance, you basically say 5 subtract 1, right? So whatever x value that you have on your right, subtract the x value that you have on your left. And it doesn't matter where you put this h. The same principle applies. You basically find the difference between these two x coordinates. And now, putting that in a different form, we can basically say that this is f of 1, and this point here is f of 1 plus 4, right? Because 5 subtract 1 is basically 4. So now this 4 comes from this h, which is basically the difference in the x values. So we can write this 5 as 1 plus 4. This is 4, it's supposed to be 4. And that is the notation that is used in most textbooks to show that from a certain point, in this case we have it as 1, you're adding some h or a change in the x values so that you can get the next x value. And we can transform this equation over here into this format. And here's why we're actually doing that. So let's say you have a parabola which looks something like that, and you want to find the average gradient between this point and that point. So the line or the straight line that you draw would look something like that. And at this point, you'll see that this point is on the, let's label this parabola as f. So this point over here is on the graph. So this is f of, if you want to find the y value here, you basically trace it down and see the corresponding x value, and the same applies here. You have a certain x value as well. These are two different x values. Now the y value at this point is f of x1, and the y value at that point is f of x2. Now applying this h thing that I talked about, which is basically the difference in the two x values, you basically are going to say that at this point, you've actually added h to get to this point. So the notation would now be, this is f of x1 at this point, and at this point we have f of x1 plus h. So we are h units away from this point. That is where the notation comes from. And now putting that into this equation, because f of x and f of whatever this is basically the same as our y values, we can now come and have this kind of notation. So the average gradient would be y2 subtract y1, which is the same principle as you did in functions. And now writing it in this new form, it will basically be a point which is h units away, and a point, you can call it the original point if you want, and then divided by the x value, subtract the original point. So these two things are exactly the same. These two things are exactly the same, just that in this new notation, we are now writing one of the x values with reference to the other. So this x value is h units away from that one. And you can also transform this into just y2 and y1, because this is y2 and that would be y1. This is x2 and that would be x1, basically. So that is where the notation comes from. It's nothing really scary or difficult to understand. And now if you try to simplify this by doing the subtraction at the bottom, because you do have x minus x over there, and now you only have h at the bottom. So this is how you basically find your average gradient. And to show this, I'm just going to do an example. And this h is basically the difference between the 2 points. So that is what that is. And now doing an example to show how you'd apply this, or how it actually works. So let's say we have a function g of x equals to 2x squared. Now let's say we are asked to find the average gradient of g. So find average gradient of g between the points with x equals -3 and x equals 5. So let's say we're trying to find the average gradient between these 2 points. Now you can start with any of these points. It doesn't really matter, but the normal thing would be to start with the one which is the rightmost x value, which would be this one. But any method or any order actually works. So now here's what we're going to do. The formula of our average gradient, and based on the definition of the average gradient, it is the gradient of a straight line that connects the 2 points. So what are these points that we're talking about? So if you were to talk about these points in terms of coordinates, you basically say f, this is g actually. So this would be g of -3. And that would be, basically substitute this to get 2 multiplied by 9, which is 18. And g of 5 would be 2 that. And that would be 2 multiplied by 25, which is 50. So writing these 2 points as coordinates, you'd have -3 as your x coordinate, and you'd have 18 as your y coordinate. Then you'd have 5 as your x coordinate and 50 as your y coordinate. So we now have these 2 points in terms of coordinates, and you can simply do what we've always done. So let me just write this. It's actually m divided by x2 minus x1. And once again, you can start with any of these points. So starting with the 50, then subtracting the 18, then divided by 5, subtract this. And at the top, you basically have 32. At the bottom, you have 8. And your answer should be 4. So this is what we have as our average gradient, and we have successfully answered the question. And to have a look at this in terms of the notation, which you don't really have to worry about. Now, if you look at 5 and -3, the h there would be 5 minus that, which is basically 8, right? Now, going back to that notation, we'd have f of -3 plus 8, subtract f of -3, divided by -3 plus 8, subtract -3. So this is what we basically have. And remember that at the bottom, we simplified this to just h, and our h is just 8, right? So this is 8. So if you do this, this is just basically f of 5. And that f of 5 we found to be this value. And this is just basically f of -3, which we also found to be that value. And this would amount to the same thing as that. And you basically have 32 divided by 8 again. So that is how you basically do it. So you can either first expand the stuff and actually write the coordinates down, which is what I did over here, or you can just simply show that you are using the original formula that we talked about previously, which is over here. So you can directly substitute into this formula, or you can use the coordinates. So that is just an overview of how you deal with the average gradient and what the average gradient is all about. If you like this video, just give it a thumbs up. If you have any questions, just leave your questions in the comments, or alternatively you can use my email, which is in the description, to contact me if you need any help or if you have any more questions. If you haven't subscribed, please subscribe, and I will see you in the next video.